Hello students, welcome back to Wings lecture. I'm Vetrimani Yalangovan. In this tutorial, I'm going to teach you about Warshall's algorithm and why we are going to use Warshall algorithm and its notations. So what is going to be the aim, why we are going to use Warshall algorithm on the graph? So the primary objective of Warshall's algorithm is to construct a transitive closure of a given directed graph. Okay, and here you can see the example. Here we have four vertices. Here we have a graph with four vertices and the edges are there, right? So here there are the directions in the edges. That's why we are calling the given graph as a directed graph. Okay, so how we are going to solve the problem by using Warshall's algorithm? The procedure is very simple, and let's start from the step one. First, what you have to do is you have to define the given problem statement. So in the definition part, what are the available terms, available datas from the problem? So first one, it is going to be n, which is nothing but number of vertices. Okay, then you can ask that how we are going to solve the problems. Already you know that how to represent the graph, right? So either we can represent the graph by using matrix adjacency matrix method, or else by using linked list method, other method, right? So here we are going to use adjacency matrix method for solving this. Okay, so we are going to use n by n matrix for all the iteration. And one more thing is from the input, from the number of vertices, you can decide that how many number of iteration you are going to have. Okay, so about the iteration and all, I will explain you while doing an example. Okay, and one more important thing is the formula, how you are going to make decision for filling up the data in the matrix. So first, let me start with the first iteration. We have to start from R0. So R0, which is nothing but adjacency matrix of a given graph. Okay, so let me draw this. You have to start from 1, 2, 3, 4, because we have 4 vertices. 1, 2, 3, 4. So the equation and the thing is very simple, that if there is a direction between one vertices to another vertices, then you can make it as 1, otherwise you can keep it as 0. That's it. So usually the diagonal will be 0 because there is no the vertices are not pointing to the same vertices, right? So what you can do is first you can fill up the diagonal. Usually it will be 0 on R0, for the first step. Okay, so then find out the edges whether it is available or not. So from 1 to 2 is available, right? Then the next step is so from 1 to 2, of course, from 1 to 2, yes, we have an edge and the direction is fine, then you can keep it as 1. From 1 to 3, is there any? No. So we have edge, but the direction is in reverse way, so it will be 0. And 1 to 4, no edges. And from 2 to 1, no. And from 2 to 3, yes, of course. And from 2 to 4, there is no edges. And from 3 to 1, yes, there is an edge. And from 3 to 2, no. And from 3 to 4, of course, we have edges. And from 4 to any other vertices, so there is no vertices from fourth vertex, so you can simply keep it like 0. Okay, so this is going to be our first set of process. So it is going to be R0, and then you can ask that, sir, we have found that adjacent matrix, then what is going to be the next step? So the process is very simple. Listen carefully. We are going to introduce one formula for finding the value for the next iteration, which is R power 1. Okay, so from the question it's already told you the number of iterations, which is very simple. See, we have to start from R0, which is nothing but it is going to be the adjacent matrix value. So that's what already we have created. Then what we are going to do is we are about to find R1, R2, R3 and R4, so which is nothing but from R0 to n. Okay, here n value is 4, right? So that's the logic. Then next, let me write the formula. R power k is R power k of I comma j, which is nothing but I is for x and j is for y axis, okay, or else you can call it as yx, no problem. Yeah, let me write the formula. R k of I comma j is equal to R k minus 1 of, we are going to use the intermediate vertex for find out the value, okay. So I comma the intermediate which vertex, which is nothing but a k, okay, and R k minus 1 of k comma j, okay, simple. I and j vertex. So we are going to check whether is there any direct connection. If not, we are going to find out is there any intermediate vertex are available. So in this way, okay, it has to satisfy both edges. Fine. So while solving the problem, you will get a clear idea. Now the next step is, let me move my screen. Now we are going to solve, we are going to find out R1 by using the vertex, by using adjacency vertex matrix. So R1 is going to be 1 2 3 4, 1 2 3 and 4. Okay, so you can ask that how to start filling the data in R1 matrix. Of course, by using this only we are going to fill it up. Okay, so apart from this, let me tell you one shortcut. If you are about to deal with R1, for example, so you can keep one over here, it's better, or 1. So you can mark, or you can select the first row, which is going to be R11. R1 means k value. You can select both this both these values, for example row and column. Then you can keep the same value over here for reducing some steps. Okay, so if you are ready to compute with this formula, of course you can do, it's better I'll do for the first one. Okay, so R1 of I comma j, here I comma j is going to be 1 comma 1, right? R1 of 1 comma 1. So what is going to be that formula? If you apply this formula, R power k minus 1, what is k here? 1, which is going to be R0 of 1 comma 1. What is the value? R0 of 1 comma 1, 1 comma 1 is going to be 0, right? So in that way, if you choose that other option, and then you can ask that sir, why we are going to use and what is going to be the condition? Obviously we will get the answer like 0 and 1, right? So when we have to choose, so when you have to keep 0, when we have to keep 1, so it has to be 1, right? Or else it has to be 0. So if we are above, our aim is we are going to make all the zeros, we are going to change the zeros into 1. Okay, so that's what we are going to do by using Warshall's algorithm. So what we are supposed to do is, when we have to change the previous matrix value, means if we are able to change it to 1, then of course we have to do. Okay, so I'm going to keep the same value for the first row and first column. Okay, yes. Now so let's start doing from the second 2 comma 2. Okay, R1 of 2 comma 2. So the formula is going to be R0 of, what is the value for k? K is equal to 1. So 2 comma, first it is going to be R0 of 2 comma 2, or we have to go to the next method, that is R0 of 2 comma 1 and R0 of 1 comma 2. So what is going to be the value here for R0 of 2 comma 2? See, R0 of 2 comma 2 is going to be 0, right? And find out is there any alternate value from this part. So if the first part is failed means then we have to try the second one. So if in the first part itself if we got the value 1 means we can skip this second part. Okay, so here r0 of 2 comma 1, r0 of 2 comma 1 is going to be 0, and r1 comma 2, of course r1 comma 2 is also, it is going to be 1. So it is 0 and 1, so it has to be either 0 or 1, but right. So if both are 1 means we can change, otherwise we cannot change this. Okay, so 0, and for this step let me erase this because it requires more space. Now the next step is r1 of 2 comma 3, and k is equal to 1, you know that. So the formula is r0 of 2 comma 3 or r0 of 2 comma 1 and r0 of 1 comma 3, right? So r0 of 2 comma 3, r0 of 2 comma 3 is 1. So here itself we have got the value 1, so no need to check in this part. Okay, so then let's make it 1, and then for the next step r0 of r1 of 2 comma 4, then it is going to be r0 of 2 comma 4 and r0 of 2 comma 1, sorry, here it is going to be r, and r0 of 1 comma 4. Then what is going to be the value here? Obviously r0 of 2 comma 4, 2 comma 4 is going to be 0, so this condition not satisfied. So go to the next one, r0 of 2 comma 1, of course that's also 0, so there is nothing to doing with this, so both r is going to be 0. Then this part completes. Then next row 3, yeah. So the value of r1 of 3 comma 2 or 0 of, what is the value of 3 comma 2? 3 comma 2 is 0, so we have to go with another part, another condition, r0 of 3 comma 1 and r0 of 1 comma 2, which is 0, and here what we have the value r0 of 3 comma 1. So here we are not checking that, we are checking that ij, if there is no direct connection means we are checking that is there any alternate connection by using the edge. So either we can go from this route. Okay, if there is no connection to reach I to j means, so we are trying another possibility. Okay, so r0 of 3 comma 1 is 1 and 1 comma 2 is also 1, so then we have to convert, we have to change the value over here as 1. Okay, so before we had 0, now we are going to change it into 1, right? Next step is for 3, of course r1 of 3 comma 3 or 0 of 3 comma 3 is going to be what? See, r0 of 3 comma 3 is going to be, already it is 0, so I have to go to the next step, which is r0 of 3 comma 1 and r0 of 1 comma 3. Then what is the value? r0 of 3 comma 1 is 1 and 1 comma 3 is 0, so we cannot choose this, we cannot use this, so it is going to be 0. And then for the next step, r0 or 1 of 3 comma 4, then what is going to be? r0 of 3 comma 4. So what is the value here? We had r3 comma 4, which is already 1, so directly we can keep it as 1 over here. Okay, and when it comes to the fourth row, it is going to be very simple one, because we know that there is no outgoing edges from 4th vertices, right? But we have to do all those steps. Or 1 of 4 comma 2, 1 is already there, 4 comma 2, then what is the value? Or 0 of 4 comma 2, 0, and or 0 of 4 comma 1, and or 0 of 1 comma 2, then 0 or 0 of 4 comma 1, which is already 0. If one part is 0, means there is nothing to do with the second one. Okay, so unconditioned, you know that both has to be 1 or 0, then only we can keep 1. So 1 comma 2 is going to be 1, but of course we cannot choose it, it is going to be 0. So for all the cases it will be 0, because we know that if we are going to deal with the row number 4, obviously it is going to be 0, right? So just to avoid the number of steps, because then it will be it will take more than 30 minutes to solve the problem. Okay, so if you want, you can try. Next, now we have completed R1. So next step is we are about to find R2. Then what you have to do is you have to select the second row and second column. So directly you can write it instead of doing it again. So 1 0 1 0 1 2 3 4 1 2 3 4, then 0 1 0. So rest of that we have to find out the rest of the positions values. So first one, or 2 of 1 comma 1, I'm writing over here. So formula is R1 of 1 comma 1. So we know that what is the value? R1 of 1 comma 1 is 0. Then find out the next option, or 0 of 1 comma 2, or sorry, and R1 here, R1 of 2 comma 1. So you know that why I am using 2 over here, because the k value is 2, or 2 is nothing but a value of k. Okay, so it is going to be R1 of 1 comma 2. R1 of 1 comma 2 is 1, and R1 of 2 comma 1, which is 0. So I cannot change this, it is going to be 0 only. Then R2 of 1 comma 3, then what is the value? R1 of it is going to be 0 for first one, and R1 to 2, R1 to 2 is R1 to 2 is 1, and 3 to 1 is 1. So 1 to 2 and 2 to 1, sorry, 2 to 3. So 2 to 3 is going to be 1. So it is 1. I'm going to change this value to 1. Then fourth one is going to be we know that first it is going to be R2 of 1 comma 4. So we know the value 0, and over here it is going to be R1 of 1 comma 2 and R1 of 2 comma 4. Obviously both are is going to be 0, right? Now coming into third row. So once you understood the logic, the rest of the process is going to be very simple. Okay, now R2 of 3 comma 1, let me move this, R3 comma 1 is equal to R1 of 3 comma 1. Then we know that 3 comma 1 itself we are going to, because we are 3 comma 1 itself, it is going to be 1, no need to write the next part. Okay, then you can keep it 1. Then 3 comma 3, it is but the value is 0. let me change the color. Okay, so value is 0. Then what you have to do, you have to try with the index. That means that k value 3 comma 2, what is value? 3 comma 2 is 1, and 2 comma 3 is, sorry, let me write this, r2 of 3 comma 3, then r1 of 3 comma 3, or r1 of 3 comma 2, and r1 of 2 comma 3. So we know that it is going to be 0, and 3 comma 2 is 1, and 2 comma 3 is 1. Okay, so both are 1, it is going to be 1. And then for 3 comma 4, r2 of 3 comma 4 is going to be r1 of 3 comma 4, or r1 of 3 comma 4, already it's 1, so no need to do this. Okay, so r1 of 3 comma 4 is 1, and we know, so our next row is going to be 0, and let's solve this. Okay, or 2 of 4 comma 1, so already the value is 0, and next part r1 of 4 comma 2, and r1 of 2 comma 1. r1 of 4 comma 2 is 0, so then there's nothing to do with this. 0, and r2 of 4 comma 2, already we know the value 0, it's there, r2 of 4 comma 3, so 4 comma 3, the previous value is 0, and r1 of 4 comma 2, and r1 of 2 comma 3. So whatever, if we choose this part, then the both value, all the value should be 0, right? So we'll get all the value as 0. Okay, so next we are going to draft the next iteration. R3. So we know that we have to take the row, third row, and third column. Okay, which is going to be same. 1 2 3 4, 1 2 3 4, 1 1 1 0 1 1 1. Okay, so let's find the value. Now it will become very easy. r3 of 1 comma 1, it is going to be 0 initially, r2 of 1 comma 1, or r2 of 1 comma 3. You know that why I'm using 3 over here, k value is 3 in this iteration, and r2 of 3 comma 1. So r2 of 1 comma 1 is going to be 0, we know that. r2 of 1 comma 1 is 0, and r2 of 1 comma 3, 1 comma 3 is 1, and r2 of 3 comma 1 is going to be 1. That means it will become 1. Then let me erase this. r3 of 1 comma 2, already it is 1, so no need to change, no need to compute the next one. And next or 3 of 1 comma 4. So this value already it is 0, so that r 1 comma 3, r2 of 1 comma 3 and r2 of 3 comma 4. So here r2 of 1 comma 3 is 1 and r2 of 3 comma 4 is 1. See this one and this, so it will be 1. And next row, or 3 of 2 comma 1 for this part. Okay, or 2 of 2 comma 1 already is 0, right? Or r2 of 2 comma 3 and or 2 of 3 comma 1. So 2 comma 3 value is 1, it is going to be 0. 2 comma 3 is 1 and r2 of 3 comma 1, obviously it is going to be 1. So you know that all the values except 3 comma 4, sorry, 4 comma 3 and 3 comma 4 is going to be 0 in this from the input of r2, right? All the values are 1. Then obviously if you are going to deal with this row, then it will change all the node to 1, right? So it is going to be 1 and let me erase this, otherwise it will not be. Or 3 of 2 comma 2 is going to be, or 2 of 2 comma 2 already 0 and or 2 of 2 comma 3 and or 2 of 3 comma 2. So both are 1, then it will become 1. And or 3 of this one 2 comma 4 or 2 comma 4, it's already 0. Then find out the next, or 2 of 2 comma 3 and or 2 of 3 comma 4. So this value will be see, it is going to be 0 or comma or 2 of r2 of 2 comma 4 is 0 and r2 of 2 comma 3 is 1, but r2 of 3 comma 4 is going to be what? 3 comma 4 is going to be 1. Then what is going to be the value? 1, right? So for the last row, or 3 of 4 comma 1, then you see, or 2 of 4 comma 1 or 2 of 4 comma 3 and or 2 of 3 comma 1. See what is the value for 4 comma 3. 4 comma 1 obviously it is 0, 4 comma 3 is 0 and r2 of 3 comma 1 is 1. So there is nothing to do with, there is no root over here, so it is going to be 0. So while doing this you will get 0. Already you know that from the graph itself it will produce no outgoing vertices to any other vertices. So just to avoid that time, I'm keeping it all those value as 0. Okay, and next go to final iteration. It is going to be r4. So for that, you know that which one you have to take. We have to take 4th row and 4th column. Then you can tell that, sir, already all the values are becomes 1. Rest of all those rest of the data from 4th row and 4th column You told that you are not supposed to change the value. That means if you perform the calculation also, the value will not get changed. Then what we have to do? It's going to be the last data. Okay, don't worry about that. 1 2 3 4, 1 2 3 4. Yeah, sir, this is going to be the last one. You can ask the doubt that, so then what is going to be the solution? So let's draw the map once again. 1 2 3 and 4. So this is going to be the map, we know that, right? Yes. Yeah, sorry. 1 2 2 and 2 2 3 and 3 2 4 and 3 2 4, right? So here using this, what we are trying to convey is we have found the data. See, we have found the path, which is nothing but the transitive closure of the given directed graph. So by using this matrix R4, you can form a map, form a graph from all the vertices, right? So we state that from the vertices 4, you cannot reach to any of the vertices. Okay, from if you choose the fourth one, you cannot reach, obviously, right? Yeah. So next, the time complexity for Warshall's algorithm is going to be, let me write this, is going to be big O of V cube. So V, which is nothing but number of vertices, or else if you take the value V as n, means it is going to be n cube. Okay, so we are going to have 3 loops. Okay, already you know that, we have seen in many asymptotic notation examples, right? So if you are about to have 3 4 loop, means the time complexity is going to be cubic. Okay, so that's it, and if you have any doubts, you can comment in comment section, or else you can mail to wingslectures@gmail.com. And thanks for watching. Thank you.